All right, this is the in-class review, day one. So the first question was find the midpoint and distance. Okay, so probably want a little bigger font, right? No, that'll be okay. Okay, so find the distance and midpoint. So we have 2 points here, -2, 4, and 3, -2. If we want to find the distance, we're simply going to use the distance formula. You could also use the Pythagorean theorem, but let's just start with the distance formula. Okay, it's the change in x squared, right, which is x2 minus x1 squared, right? The difference between the two x values. So the change in x squared plus then the change in y squared. So y2 minus y1 squared. Okay, your two x values are -2 and 3. So if we substitute in our values here, we're going to have the square root of -2 minus 3 squared plus then your two y values. Your two y values are 4 and -2. So I'm going to do 4 minus -2 squared. Okay, so simplify there, -2 minus 3. That's going to give us -5 squared plus 4 minus -2 is a +6. So that's going to give us 6 squared. Okay, and then square root, that's going to be 25, +25, right? When you square, you're multiplying it twice. So -5 times -5 is a +25. And then 6 times 6 is a +36. So that's going to be the square root of 61, which is approximately, if we put that in our calculators, the square root of 61 is going to be approximately 7.81. Right? So approximately 7.8. It doesn't really tell us how many decimals to round to, so how about 7.81? Okay, the other way you could do it here is you could use the Pythagorean theorem if that's easier for you. Okay, the distance here is 5. The distance here is 6. If you make this x, then you could do, 5 squared plus 6 squared equals x squared, right? And that's 25 plus 36 equals x squared. So 61 equals x squared. So you square root both sides, and you'd get approximately 7.81 equals x. Okay, so you can use the distance formula, or if you want to use the Pythagorean theorem, that's fine, because the Pythagorean theorem is essentially the distance formula. They're the same thing. All right, then the second part here is midpoint. So that's distance. Now we need the midpoint. So the midpoint formula is just the average of the two x values and then the average of the two y values. So y1 plus y2 over 2. Okay, so your two x values are -2 and 3. So we're going to take -2 plus 3. Oops, it's not going to let me write on that part. So -2 plus 3 divided by 2. And then your two y values are 4 and -2. So 4 plus -2 divided by 2. Okay, so your midpoint here is going to be 1/2. Right, and then 4 plus -2 is 2. 2 divided by 2 is 1. So then your midpoint is 1. I'm sorry, 1/2 comma 1. Okay, and again, we said in class 2, this point's actually a little off. -2, 4 is actually right here. So whoever made this was a little wrong. So the line really should have been from here to here, which would make your midpoint right here. So the diagram's a little bit off from where they labeled the points. All right, the second slide here, we're not going to do the bisector one. We didn't talk about that in class. Well, in the review in class, we did talk about it in topic 1, but we're taking it off there for the final. So here we have segment addition. We're going to use the segment addition postulate, which is just if you have 3 collinear points, and if one point is between the other 2 points, then the 2 small pieces are going to add up to the big piece. So if J is between C and T, then CJ plus JT is going to equal CT. So here we have CJ plus JT is going to equal CT. Okay, so that's going to give us CJ here is 5x plus 7. So maybe if we write it in our diagram here, CJ is 5x plus 7. CT, the whole thing here, is 34. Right, and then this piece here is 4x plus 9. So CJ, 5x plus 7, plus JT, 4x plus 9, is going to equal the whole thing, which is CT, which is 34. Okay, so 5x plus 7 plus 4x plus 9 equals 34. This first piece plus the second piece equals the whole thing. Right, that's segment addition. All right, combine like terms, you're going to have 9x. You're going to have 16. So 9x plus 16 is going to give us 34. We can subtract 16 from both sides. So we're going to end up with 9x equals 18. And then we can divide 9 on both sides. So we're going to get x equals 2. Okay, x equals 2 is not our final answer. We're looking for JT. So we want to plug it back in here. So JT is going to equal 4x plus 9. So 4 times 2 plus 9. Okay, which is going to give us an answer of 8 plus 9, which is 17. Okay, so JT is 17. All right, if we wanted to check our answer, we'd have to plug in 2 for the other one. So we could have done 5 times 2 plus 7 for CJ. So CJ here is also going to be 10 plus 7 is 17. Okay, and then 17 plus 17 equals 34, so we know we have the right answer. Okay, or it's very likely that we have the right answer. All right, next one we did here was an angle addition problem in class. So we didn't do the angle bisector, but angle addition, so the first angle plus the second angle is going to equal the whole thing. So part plus part equals whole. So measure of angle R, this should be a Q, RQS plus the measure of angle SQT, or TQS, they use TQS. It's the same angle. Okay, equals the whole thing, which is the measure of angle RQT. Right, so RQS plus TQS equals the whole thing, which is RQT. Right, from there we have all the pieces, we can just substitute them in. So the measure of angle RQS here is 4x minus 20. The measure of angle TQS is 3x plus 14. And the measure of angle RQT is 155, right? 155. Okay, so we combine like terms. That's going to be 7x. We have minus 20 and positive 14. That's going to be minus 6. And then the whole thing is 155. Okay, we add 6 to both sides. That's going to give us 7x, right, equals 161. Okay, which is going to give us x. Let's see. 7, 161, 14, looks like 23. It's going to be 23. Okay, and we want to find the measure of RQS and TQS here. So let me change colors. They don't have a really good blue, I guess, but no, that one was fine. Let's change this to a nice dark blue. There we go. Okay, so 4 times 23, right, minus 20, right? That's the measure of RQS, 4 times 23 minus 20. That's 46 times 92 minus 20 is 72. Okay, so this angle here is going to be 72. Right, and then over here you have 3 times 23 plus 14. All right, 3 times, so substitute in 23 plus 14, that's going to be 69 plus 14. That's 7383. Okay, and to check our answer, 72 plus 83, the whole thing here is going to be 155. So 72 plus 83 equals the whole thing 155. So we know we're good. All right, the next one here is a proof. So we're given that xy equals 42. So the whole thing here is 42. And we're given that 3 times n plus 4 is xz, and then zy here is 3n. So we're just going to use our segment addition postulate, right? So z is between x and y. So the first piece xz plus the second piece zy equals the whole thing xy. That is your segment addition postulate. Okay. And then once you have your segment addition postulate, you're simply substituting in your values. So xz here is 3 times quantity n plus 4. Zy is 3n. And then xy here is 42. So we just substitute those in. That's substitution. Substitution. Okay. From there, we are going from 3 times quantity n plus 4 to 3n plus 12 by distributing. Right, we're distributing. So that's the distributive property. Property. Okay, and from there, we're combining like terms. So 3n plus 12 plus 3n equals 42. So that's going to be combining like terms. I should have typed these. Combining like terms. Right? Or just simply simplify. Simplify. Okay, and then we're using the subtraction property of equality. We're subtracting 12 from both sides. Right, so that is the subtraction property of equality. And then we're dividing both sides by 6. So that is the division property of equality. Right, and there's your proof there. But again, on the test, it's not going to be open-ended. You're going to have drop-down menus to pick. All right, next one. We didn't go over this one in class, but it was the same process. Right, so you would do AB plus BC equals AC. And then you would substitute in, so you'd have 2y plus 3y minus 9 equals 21. And then you'd simply combine like terms. You'd add 9 to both sides and then divide by 5. So it's pretty simple there. We didn't do that one in class, so I'm going to skip it here. Same with those. Same with these. Okay, we did name these. So these are our angle pairs. So let me actually type these out. Is much easier. Okay, so corresponding angles are angles if you pick up the intersection and put it on top of the other intersection. The ones that are on top of each other are corresponding. They're in the same corresponding location. So 5 and 1, 6 and 2, 8 and 4, 7 and 3. Those would be your corresponding angles. So angle 1 and angle 5 are in corresponding locations. Angle 2 and angle 6 are in corresponding locations. Angle 3 and angle 7. And then angle 4 and angle 8. Okay, 1 and 5, 2 and 6, 3 and 7, 4 and 8. They're in corresponding locations. If you pick up the intersection and put it on top of the other one, those will match up. Okay, alternate interior angles are on alternate sides of the transversal. So line T here is the transversal. It cuts through the two other lines. It transverses the other two lines. It cuts through line M and line N. So alternate interior angles are going to be on the alternate side of that transversal and in between the two lines. So 3 and 6, 4 and 5. The alternate interior angles here are going to be angle 3 and angle 6. Okay, and angle 4 and angle 5. Okay, alternate exterior angles are on alternate sides of that transversal and outside of the two lines. So 1 and 8 would be alternate exterior, and then 2 and 7. So angle 1 and angle 8. Okay, and then angle 2 and angle 7. Okay, same side interior. So they're on the same side of the line T, transversal, and then they're in between your two lines here, M and N. So 3 and 5, and then 4 and 6. So same side interior are going to be angle 3 and angle 5. And then angle 4 and angle 6. Okay. Same side exterior angles are on the same side of the transversal and on the outside of those two lines, M and N. So 1 and 7, and then 2 and 8. So angle 1 and angle 7, angle 2 and angle 8. Okay, vertical angles are formed when two lines intersect. The formal definition talks about being formed by two pairs of opposite rays. We can just think of it as opposite sides of an x. Okay, so for example, angle 1 and angle 4. Right, we also have angle 2 and angle 3 are vertical. Angle 5 and angle 8 are vertical. And then angle 6 and angle 7 are vertical. Okay, and then there's a bunch of different linear pairs. Linear pairs are adjacent and supplementary, so they add up to a straight line. So we have angle 1 and angle 2. We have angle 2 and angle 4. We have angle 4 and angle 3. We have angle 3 and angle 1. And then we have angle 5 and angle 6. Angle 6 and angle 7. Angle 8 and angle 7. Oop, not 6 and 7, I'm sorry. 5 and 6, 6 and, I got ahead of myself. 6 and 8. 8 and 7. And angles 7 and angle 5. Right, 1 and 2, 2 and 4, 4 and 3, 3 and 1, 5 and 6, 6 and 8, 8 and 7, 5 and 7. Right, forms a straight line, adjacent and supplementary. Okay, so now let's look at congruent or supplementary. So actually, let's go to drawing here. Right, so vertical angles are always congruent. Okay, and linear pairs are always supplementary. So maybe write it over here. Congruent, right, supplementary. Okay, and then if the lines are parallel, your corresponding angles are congruent. Right, your alternate interior angles would be congruent if the lines are parallel. Your alternate exterior angles would be congruent. Your same side interior angles would be supplementary. And your same side exterior angles would be supplementary as well. Okay, so vertical angles always congruent, and then if your lines are parallel, your corresponding alternate interior, alternate exterior angles would be congruent as well. Your linear pairs are always supplementary, but if the lines are parallel, then the same side interior and same side exterior angles are also supplementary. Okay, and then we have this one here. Find the value in x, given that lines L and M are parallel. So we do know angles L or lines L and M are parallel here. Okay, so if we look at number 1, measure of angle C is 3x plus 10. Measure of angle X, or F, is x plus 70. So those are alternate interior angles, and since the lines are parallel, your alternate interior angles are congruent. And since they're congruent, you can set them equal to each other. So 3x minus 10 is going to equal x plus 70. Okay, you subtract x from both sides, you're going to get 2x minus 10 equals 70. Okay, you add 10 to both sides, you're going to get 2x equals 80. You divide by 2, and you're going to end up with x equals 40. Okay, and then you can plug those in just to double check here. So we'd have 3 times 40 minus 10. That's 120 minus 10, which is 110. And then you also have 40 plus 70, which is going to be 110. So it looks like we're good. Those two measures are equal. All right, let's look at measure of angle D and the measure of angle F here. Okay, those are same side interior angles. So since the lines are parallel, they're going to be supplementary. Supplementary angles are angles whose measures add up to 180. So instead of setting them equal to each other, we're going to do x plus 27 plus 2x minus 39 equals 180. Okay, and then we combine like terms. We're going to have 3x. We have positive 27 and negative 39. That's going to be minus 12. Okay, you add 12 to both sides. That's going to be 3x equals 192. Okay, let's see. 3 goes into 192. That's 64. So x is going to be 64. Right, because you'd have 12 left. All right. Okay, and then if we want to double check our answer, we can substitute that into our answer choices and make sure the numbers add up to 180. So 64 plus 27. That's 71, 81, 91. Okay, and then 2 times 64, which is 128, minus 39. So minus 28 and then minus 11. That's 100 minus 11 is 89. 91 plus 89 equals 180. So we know we're good. All right. The next one here, B and G. Okay, those are alternate exterior angles. And since the lines are parallel, your alternate exterior angles are congruent. So we're going to set these two equal to each other. So 2 times quantity x plus 40 equals 5x plus 44. Okay, distribute the 2. So 2x plus 80 equals 5x plus 44. Subtract 2x from both sides. We're going to get 80 equals 3x plus 44. Okay, subtract 44 from both sides. You're going to get 36 equals 3x. Divide by 3, and you get 12 equals x. Okay, if we substitute it back in just to make sure here. So 2 times 12 plus 40. So that's 52 times 2 is 104. Okay, and then we have 5 times 12 plus 44. So 5 times 12 is 60. 60 plus 44 is 104. So we know we're good. Okay. So you just have to check the angle pairs, see if they're congruent or supplementary. If they're congruent, you set them equal to each other. If they're supplementary, you add them up to 180. Okay. All right, next one here. In each scenario, lines L and M are parallel. Explain your answer using angle relationships. So are they parallel? So A and H here. Okay, A and H. Those are alternate exterior angles. Okay, and so if alternate exterior angles are congruent, then the lines are parallel. These are not congruent, right? So this is going to be a no. In order for the lines to be parallel, alternate exterior angles have to be congruent. Okay, if we go to the next one here, C and E. Okay, in order for the lines to be parallel, those are same side interior angles. They would need to be supplementary. 50 plus 50, right? 50 plus 50 does not equal 180. So we say no. Okay, if we did green here, we would say 50 does not equal 130. Okay. This one here, F and C, right? Those are alternate interior. And if the alternate interior angles are congruent, then the lines are parallel. So this one is going to be a yes, right? 50 equals 50. Okay. And then the last one here we can do in purple, D and F, right? Those are same side interior angles. So yes, because the same side interior angles are supplementary. 50 plus 130 equals 180. Yep. Okay. And then the last one we're going to do here for day one, okay, is this one here. So linear pairs. Let's see if we can get a line in here. Okay, linear pairs, right, are two angles that, well, we probably got to draw them really small here if I'm going to draw them all in. Let's see how we're going to do this. Let's try to get a drawing for each of these, supposedly. Right, so this is a 1 and a 2. Right, so that's linear pair. Shapes. Okay, vertical angles will be next. Extend this one out a little bit. Okay, vertical angles are basically opposite sides of the x, right? Two pairs of opposite rays form vertical angles, right, where they intersect, share the same vertex. Okay, perpendicular bisector. Right, perpendicular means that they form right angles where they intersect. Two lines intersect and form right angles are perpendicular. Why is it delaying the start of these lines? Whatever. Okay, so there's perpendicular. If I can get it exactly at 90, there you go. And we can draw in right angles here. Okay, and then it's also a bisector if the two pieces are split, if the segment or angle is split in half. So if this gets split into two equal pieces here, right, if this was A and B and C and D, right, DC is a perpendicular bisector of AB because a DC is perpendicular to AB and it splits AB in half. AC and CB would be congruent there. Okay, parallel lines, right? So L and M here are parallel. So M is parallel to L, right? They never intersect. They go on forever and they never intersect. Those are parallel lines. So, and then this is our symbol for parallel, right? An angle bisector is going to split an angle in half. So let's go back to our line here. Let's draw an angle. It really is bothering me that it's delaying. Right, so there's an angle. Why don't I start up here and connect it to there? How's that? Okay, so an angle bisector is going to split an angle in half. So if we have the big angle here, A, B, C. Okay, and then we have, for example, ray DB. Right, we probably should extend my angle out. Right. Okay, so ray DB here is going to bisect the angle ABC. So that's an angle bisector. Okay, a point, right, has no size, no dimensions. It just represents a location. We use a dot to represent where the point is, and then we simply put a letter next to the dot. So this would be point A. Okay. A line, goes on forever in two directions. Okay, to name a line, we use 2 points on that line, any 2 points, right? A line is made of an infinite number of points. We're just going to pick 2 points on that line, right? And we'll call this line AB. Okay. All right, angle. So we've already kind of drawn an angle, but let's draw another one. All right, so here is a, sure. All right, here's an angle. Okay, and we're going to say this is A, B, C. All right, and then we can name this angle simply by calling it angle ABC. Okay, perpendicular to. So for example, if we say AB, and then you put the upside down T. So line AB, for example, is perpendicular to line BC. Okay, that's what that symbol means there. And again, if we go to the shapes, we can draw it out. If they let us. Close enough. Okay, so these would be perpendicular. AB, right, and then BC. Arrows here, arrows here, arrows here. Right, those would be perpendicular. Okay, and then congruent to. So that's just our symbol. For example, segment AB, right, is congruent to BC. Okay, this would be congruent to, and this would be perpendicular to. Okay, so tried to parcel it off as well as I could there. Okay, so we have linear pairs, we have vertical angles, we have a perpendicular bisector, we have parallel lines. There's the symbol for parallel. We have an angle bisector. DC is splitting the big angle in half. Here's what a point would look like, and we can name it point A. Here's a line. Line has an infinite number of points, and name it with pick any 2 points on the line, and then you put the line on top of it. So there's line AB. And then here's angle ABC. And then this here means perpendicular to, and this here means congruent to. All right, so that's essentially day 1 of our in-class review. We'll do 2 more videos for day 2 and day 3.